For the last century, the dominant anxiety about extinction from space has been a rock. A rogue asteroid, silent and fast, arriving without warning. We have built global monitoring networks around that fear, but there is a confirmed, recurring, documented planetary threat that has already struck multiple times during human history. And it does not come from the dark. It comes from the light. The star at the center of our solar system has, on several occasions, unleashed blasts of energy so extreme that they chemically altered Earth's upper atmosphere within hours. Prehistoric humans watched the sky turn blood red from pole to equator. They survived. The question is not whether they were lucky. The question is why they could survive it at all, and what happens to us when it happens again. In 2012, the scientific consensus on solar behavior was straightforward. The sun operated on a predictable 11-year cycle of magnetic activity. Flares and coronal mass ejections occurred regularly, and the strongest on record, the Carrington event of 1859, had disrupted the telegraph network. That was the upper bound. That was what we thought the sun could do. The Carrington event induced electrical currents powerful enough to spark telegraph pylons, ignite paper near the equipment, and shock operators through their keys. Some operators disconnected their battery packs entirely and continued transmitting, using only the ambient electrical energy pulled from the sky. At the time, that was extraordinary. As a baseline for the sun's maximum output, it turned out to be a significant underestimate. The assumption of solar stability was not unreasonable. It was built on every instrument reading available. What it lacked was a deep enough archive. The written human record extends back perhaps 5,000 years. The sun has been operating for 4.5 billion. To find what the sun is actually capable of across that full span, you need a different kind of record. One that predates writing, predates agriculture, predates permanent settlement. It turns out that record exists. It has been growing quietly in forests for millennia, and no one knew how to read it until a doctoral student in Japan looked closely at a single cedar tree. Fusa Miyake was a doctoral student at Nagoya University when she began analyzing the preserved rings of an ancient Japanese cedar. Dendrochronologists, scientists who study tree rings, had long used ring sequences to calibrate radiocarbon dating. Each ring represents 1 year of growth. The chemistry of that ring reflects the chemistry of the atmosphere during that year. It is a passive, continuous, high-resolution record. Miyake was working through the rings corresponding to the years 774 and 775 CE when she encountered an anomaly she could not explain. The concentration of carbon-14, you'd say a radioactive isotope of carbon, spiked by approximately 12% within a single ring. Background fluctuations in C14 are normal, but they run in the range of 0.5%. A 12% jump in 1 year was not a fluctuation. It was a signal, and it was roughly 20 times larger than anything previously recorded. The initial response from the scientific community was skepticism, a localized preservation error perhaps, a flaw in the sample. Miyake's results were checked and rechecked. Then independent research teams began looking at other trees. An oak preserved in Germany showed the same spike, dated to the same year. Bristlecone pines in the American Southwest, trees famous for their age and the precision of their ring records, showed it too. Kauri trees in New Zealand, the same anomaly in the same year, on 4 separate continents. Whatever had happened in 774 CE had happened to the entire planet simultaneously. The carbon spike was not a measurement error. It was a global event, and it had left an identical chemical fingerprint in every tree on Earth that was alive to record it. To understand what that fingerprint means, you need to follow the chain from the sun to the wood. When the sun undergoes an extreme eruption, it releases a coronal mass ejection, a massive burst of magnetized plasma, along with a wave of solar energetic particles, primarily protons, accelerated to near the speed of light. These protons travel outward through the solar system, and if Earth is in the path, they arrive within hours. Earth's magnetic field deflects most of the continuous solar wind toward the poles. During a standard flare, that deflection holds. During an extreme event, it does not hold completely. The protons penetrate deep into the upper atmosphere, where they collide with stable nitrogen atoms. That collision, known as spallation, is energetic enough to shatter the nitrogen nucleus and reassemble it as carbon-14, radioactive isotope that does not occur in significant quantities through any other atmospheric process. Carbon-14 rapidly oxidizes to form radioactive carbon dioxide. Trees absorb CO2 continuously through photosynthesis, incorporating the carbon into their cellular walls, specifically into a structural compound called alpha cellulose. Because each ring represents exactly one growing season, the C14 ratio locked into that ring is a direct measurement of the atmospheric C14 concentration during that year. A massive solar proton event produces a massive atmospheric C14 spike, and the trees record it permanently. The same solar event produces two additional isotopes that take a different path. Beryllium-10 and chlorine-36 attach to atmospheric aerosols rather than being absorbed by plants. They fall as precipitation and accumulate in snow layers, eventually compacting into the ice sheets of Greenland and Antarctica. When researchers aligned the C14 spikes in tree rings with the Be10 and Cl36 spikes in ice cores from both poles, the signatures matched precisely. That match rules out alternative explanations. A supernova or gamma ray burst would produce a different isotopic profile. The combination of C14, Be10, and Cl36 in the ratios observed is the specific fingerprint of an extreme solar eruption and nothing else. The method works because it is overdetermined. 3 independent isotopes preserved in 2 independent biological and geological archives spread across multiple continents, all pointing to the same cause. The scientific term for this is convergent evidence. The practical meaning is that the conclusion is not vulnerable to a single point of failure. The events of 774 CE and 993 CE are significant, but they are not the largest Miyake event in the record. That distinction belongs to an event that occurred more than 16,000 years ago, and its discovery was recent. Researchers examining sub-fossilized tree remains pulled from the eroding banks of the Druzé River in the southern French Alps found a C14 spike dated to 14,322 BCE. It was nearly double the magnitude of the 774 CE event, the largest solar superflare yet identified. The trees that recorded it were growing during the Bolling-Allerud interstadial, a brief warm pulse within the last ice age, when massive continental ice sheets had begun their first significant retreat and the mammoth steppes still covered vast stretches of Europe and Asia. The humans alive in 14,322 BCE in Europe belonged to the Magdalenian culture, anatomically modern Homo sapiens operating at the far end of a long tradition of refined Upper Paleolithic technology. They were nomadic, they did not build permanent structures. But nomadic does not mean simple. Magdalenian toolkits included the Atlaytel, a spear-throwing device that dramatically extended the range and force of projectile hunting. They used eyed sewing needles made from bone to construct tailored thermal clothing, fitted garments capable of protecting against severe cold, not just draped animal skins. They carved intricate figurines and engraved geometric patterns onto bone and antler, and they painted. The cave art of Lascaux and Altamira dates to the Magdalenian period. Images executed with compositional sophistication, using perspective, overlapping figures, and color blending on curved stone surfaces deep inside mountain systems. These were people with a developed relationship with the natural world, including the night sky. In the absence of artificial light, the sky above a Magdalenian camp was a navigational tool, a seasonal calendar, and a feature of whatever cosmological frameworks they carried. When the 14,322 BCE superflare struck, the proton wave reached Earth within hours of leaving the sun. The magnetosphere compressed under the force of the coronal mass ejection. The auroral oval, the ring around the poles where the aurora typically occurs, was pushed violently equatorward. People living in what is now southern France, the Iberian Peninsula, North Africa, and far beyond would have watched the sky begin to change. The dominant color was red. Energetic solar protons colliding with monatomic oxygen at altitudes above 240 kilometers produce a specific wavelength of light in the deep red range. The emission process is slow. Oxygen atoms take time to release the photon, which means the red glow is persistent. It does not flash and fade, it builds and holds. A sky that begins glowing faintly red at the horizon darkens and deepens over hours until the entire visible atmosphere is saturated with crimson light. This would have lasted for days. Lower in the atmosphere, collisions with molecular nitrogen and denser oxygen produce shifting curtains of green, blue, and purple. The magnetic field lines distorting under the CME's pressure caused the light to move. It pulsed and twisted. Bright columns appeared and dissolved. The entire sky was in motion. radiating colors that had no precedent in any Magdalenian's experience or memory. There was no framework for this, no recorded tradition, no elder's account, no myth that described the sky turning red and staying red for 3 nights while ribbons of green fire moved overhead. A person standing outside a Magdalenian camp in the southern French Alps in 14,322 BCE, looking up at that sky would have had every rational reason to conclude that something irreversible was happening to the world. And then the sun rose on the 4th day and the sky was blue, and the mammoths were still on the steppe, and the rivers still ran. The 14,322 BCE event was not an isolated occurrence. It was one point in a pattern. In 7,176 BCE, tree rings from subfossil pines in the Swiss Alps and bristlecone pines in California recorded another Miyake event. This date falls precisely within the pre-pottery Neolithic B period in the Levant, a moment of fundamental transformation in human lifeways. The people in settlements like Jericho were no longer strictly mobile foragers. They were cultivating early strains of einkorn wheat, barley, and lentils. They were domesticating the first livestock, sheep and goats. They were building the first permanent rectangular mud brick houses. They were practicing ancestor veneration by plastering and preserving the skulls of the dead, embedding the faces of previous generations into the walls of their homes. For these people, the sky was already interpreted through frameworks more organized than those available to Magdalenian nomads. Nascent religion, agricultural omens, the relationship between celestial events and crop cycles, the burning sky of 7,176 BCE would have arrived inside an interpretive structure that gave it meaning, even if that meaning bore no resemblance to the actual mechanism. In 5,259 BCE, the event happened again, and this time it was recorded in a way that changed the practice of archaeology permanently. Despilia was a Neolithic settlement in northwestern Greece, built over Lake Orestiada on wooden platforms supported by stilts. The inhabitants farmed, fished, wove textiles, produced pottery, and worked in early copper metallurgy. When the settlement was eventually abandoned and the structures collapsed into the lake, the waterlogged, the anaerobic sediment preserved the timber for over 7,000 years. When researchers examined that timber and found the 5,259 BCE spike within its rings, they could identify the spike and count the subsequent rings outward to the edge of the wood, establishing the precise calendar year in which the trees were cut. The people of Despilia had been dated, not to a century, not to a cultural phase, but to a specific year. It was the first time in the history of archaeology that a human community was anchored to a single point in the calendar. The wood they used to build their homes had been carrying that information for 72 centuries. The Anglo-Saxon Chronicles entry for 774 CE notes that a red crucifix appeared in the heavens after sunset. The description is consistent with the physics of a low-latitude oxygen aurora, a persistent red glow in the sky that to a medieval English observer resolved itself into the shape most culturally available for a sign in the sky. At Lanso Meadows in Newfoundland, the 993 CE spike in preserved timber allowed researchers to count rings forward to the bark edge and establish that Vikings were cutting wood in North America in exactly 1021 CE, the most precise dating of Norse presence in the Americas ever achieved. The events of 14,322 BCE, 7,176 BCE, 5,259 BCE, 774 CE, and 993 CE are not a list of historical curiosities. They are a recurrence interval. The Sun has produced Miyake-class events roughly once every 1,000 years across the full span of recovered tree ring data. That interval does not suggest these events are exceptional. It suggests they are routine. Before examining what a Miyake event does to modern infrastructure, it is worth establishing what a much smaller event did to the only electrical network that existed in 1859. The Carrington event struck in September of that year. Richard Carrington, a British astronomer, observed the solar flare directly through his telescope, one of the first humans to witness a solar eruption in real time. Within 18 hours, the coronal mass ejection reached Earth. The only widespread electrical infrastructure on the planet at the time was the telegraph network, a system of copper wires strung between wooden poles across North America and Europe. The rapidly changing magnetic field induced by the CME drove electrical currents through those wires. Telegraph pylons sparked at the connection points. Paper near the equipment caught fire. Then operators receive severe electrical shocks through their keys. In several documented cases, operators disconnected their battery packs entirely and continued to send and receive messages using only the current induced in the wire by the geomagnetic storm, ambient electricity drawn directly from the sky. The Carrington event is estimated at roughly x40 to x50 on the solar flare scale. A Miyake-class event is estimated at 10 to 100 times more energetic than a severe solar storm of that category. The Carrington event disrupted a telegraph network. A Miyake event hits a planet wrapped in millions of miles of high-voltage power lines, undersea data cables, and orbital infrastructure. The mechanism of destruction is Faraday's law of induction. A rapidly changing magnetic field induces electrical current in any conductor within range. Yet in 14,322 BCE, there were no long conductors on the surface of the Earth. There were no power lines, no pipelines, no railway tracks, no submarine cables. The induced currents had nothing to flow through. In the modern era, those conductors are everywhere. The critical vulnerability is the extra high voltage transformer. These are the large custom-built machines, some weighing hundreds of tons, that step electrical voltage up for long-distance transmission across the grid and down again for local distribution. They are not interchangeable. Each is built to specification for its location in the network. When a Miyake event drives massive direct current into an alternating current grid, the copper windings inside these transformers saturate magnetically. The cores overheat. The insulating oil boils. In the worst cases, the transformer fails catastrophically, copper and steel components melting into slag, sometimes accompanied by fire and explosion. The manufacturing lead time for a replacement HV transformer is 12 to 24 months under normal conditions. A Miyake event does not destroy one transformer. It destroys hundreds or thousands simultaneously across every continent with a developed electrical grid within the same hours-long window. There is no stockpile. There is no rapid manufacturing surge that closes a 2-year lead time. Parts of the grid, once down, stay down. The global internet does not fail through the same mechanism, but it fails nonetheless. Undersea fiber optic cables span the ocean floors carrying intercontinental data traffic. Glass fiber does not conduct electricity, but the signal degrades over distance. Yet every 40 to 50 miles, the cable requires a repeater, a powered device that amplifies and retransmits the optical signal. To power those repeaters across thousands of miles of ocean floor, each cable bundle includes a continuous copper sheath carrying high voltage along its entire length. That copper sheath is an ideal conductor for geomagnetically induced currents. A Miyake event drives a surge through the oceans, frying the repeaters and severing every intercontinental internet connection simultaneously. Financial systems freeze, logistics networks lose coordination, cloud infrastructure becomes physically inaccessible. Satellites are hit directly by the high-energy proton barrage. Shielding that adequately protects against ordinary solar activity does not protect against a flux 10 to 100 times higher. Protons penetrate the electronics, flipping memory states and short-circuiting components. Simultaneously, the intense radiation heats the upper atmosphere, causing it to expand outward. Satellites in low Earth orbit suddenly experience increased atmospheric drag. Their orbits decay faster than expected, and without functional GPS and ground communications, corrective burns become impossible to coordinate. Aviation halts. High-frequency radio communications over the poles go silent. Passengers and crew aboard commercial aircraft at 35,000 feet during the peak of the event are exposed to ionizing radiation doses that exceed safe limits by orders of magnitude. There is a precise inversion at the center of this story, and it is worth stating clearly. For prehistoric humans, a Miyake event was a maximally visible experience and a minimally dangerous one. Earth's magnetic field and the mass of the atmosphere absorbed the radiation before it reached the surface. The people who watched the sky turn red over the Druze River Valley in 14,322 BCE, or who saw that same red light reflect off the surface of Lake Orestiada in 5,259 BCE, felt nothing. No radiation sickness, no burns, no biological consequence of any kind. The event was terrifying as spectacle. As a physical threat to human bodies, it was essentially zero. For modern humans, the inversion is complete. A Miyake event arriving today would produce some visible auroras at lower latitudes than usual, perhaps noticeable in mid-latitude cities. Yet the people standing outside watching the light show would feel nothing. No heat, no pressure wave, no visible destruction. And in those same hours, the transformer banks would be saturating and failing. The submarine cable repeaters would be burning out. The satellite memory arrays would be accumulating fatal errors. The physical danger in the modern scenario is almost entirely indirect. 8 billion people depend on electrical grids for water treatment, food refrigeration, hospital operation, heating, and communication. A grid that is down for months, not days, is not an inconvenience. It is a cascading failure across every system that depends on it. The people watching the aurora would not know in those first hours that they were watching the moment their infrastructure stopped. This is the specific vulnerability that makes Miyake Events unlike any other natural disaster. A hurricane is visible, an earthquake announces itself. A Miyake Events destruction is invisible, instantaneous across a hemisphere, and concentrated entirely in infrastructure rather than bodies. The Magdalenian hunters who survived the largest known superflare on record did so not because they were resilient in any modern sense. They survived because they had nothing to destroy. The chronology assembled since Miyake's 2012 discovery is specific: 14,322 BCE, 7,176 BCE, 5,259 BCE, 774, 993 CE. An international collaboration of dendrochronologists and physicists known as the Cosmic Initiative continues to search for additional events in the expanding archive of ancient preserved wood. The events already confirmed span roughly 15,000 years of the tree ring record, and that record is necessarily incomplete. Organic material survives only under specific conditions: waterlogged sediment, frozen permafrost, dry desert environments. Every confirmed Miyake event is an event that happened to leave datable wood behind. The events that left no surviving archive are invisible to the method entirely. The 5 confirmed events are a lower bound, not a complete census. Statistical analysis of the confirmed recurrence interval suggests a Miyake-class event occurs roughly once every 1,000 years. That estimate carries uncertainty, and the true interval may be shorter or longer. What it does not support is the idea that these events are once in 10,000-year anomalies. The data points cluster too closely for that interpretation. They are periodic, they are recurring. They are a feature of the sun's behavior over human timescales, not an exception to it. The gap between the last confirmed event in 993 CE and the present is just over 1,000 years. There is no planetary defense budget for this. There is no Miyake event equivalent of the asteroid survey programs that map near-Earth objects years in advance. The hardening of electrical grids against geomagnetically induced currents is technically feasible. Neutral blocking devices can protect individual transformers. But the scale of implementation required globally has not been achieved. The transformer manufacturing bottleneck has not been addressed. The submarine cable infrastructure has not been redesigned with surge protection at the repeater level. When the Magdalenian hunter in 14,322 BCE looked up at the burning sky, survival required nothing. The radiation stopped at the top of the atmosphere. The prey animals did not die. The rivers ran. The hunter woke up on the 4th morning to a world that was functionally unchanged. The next Miyake event will produce the same aurora. The same blood-red oxygen glow will spread from the poles to the equator. Yet the same green and purple curtains will writhe across the sky above cities that have never seen an aurora. People will step outside into the cold or the warm night air to watch. The sky will look exactly like the end of the world. For the Magdalenian, it wasn't. The question the tree rings are asking, quietly, in isotope ratios locked into wood that has outlasted every civilization that grew beside it, is whether the same will be true for us.